All right, let's keep simplifying. So what if I gave you the square root of 48?
Oh, there you go.
How do you think you would break this down? Is it a perfect square?
No.
It's not. Could you find factors that are?
Yes.
How? You think? You
Factor
don't
it.
know?
The factor.
How are you going to factor this?
6 times 8 is 48.
16 times 3.
Is it 6 times 8 is 48?
6 times 8 is 48.
Okay. So I need
Greg
to
says
work.
16 times 3.
Oh, 16 times 3 is good.
Is that right?
I don't know.
Are you telling me I could do 16 times 3?
Mm-hmm.
Wait, and 16 is a perfect square? Are you kidding me? What's the square root of 16?
4.
So 4 comes on the outside of the radical. And who is not a perfect square? Who's the losery guy? Yeah, you can just stay inside. Don't worry, I've been the radicand a lot in my life. Okay. So I'm done. Isn't that great? Now, Singray, you're looking at me like, Mr. Craig, like I'm even going to know that 48 is 3 times 16.
You talking to me?
No, I'm talking to the other Singray.
Oh, this is Greg. Oh, I said Greg. Excuse me. Oh, you're really here.
No, she wasn't talking to you. She didn't say Mr. Greg. Although it was, if I ever go back into radio, that's going to be my name. Brian Gregg. Never mind. So suppose you didn't know that. You said 6 times 8, right?
Yeah, 6 times 8 is 48. I remember.
Neither one of those is a perfect square.
No, but you can break down them both.
I can break down 6 to be what?
2 and 3.
2 times 3, what about 8?
4 and 2.
Well, I know that 8 is 2 to the third, so I'm just going to write down the 3 factors of 2.
So it's 2 and 4 and 6.
Is this broken down all the way? Is that correct? Now, are any of these guys perfect squares?
All the 2s.
They're not perfect squares, but if I pair these guys up, is that guy a square? That guy's a square, and that guy's also a square. Do you believe me? If I have 2 factors of 2 inside the square root, what does that give me on the outside? That gives me a 2. What about these 2's right here? What do they give you? What do you do with those 2's that are outside? Add them? I want you to tell me why you add them when everything else in this problem is multiplication.
2 plus 2 is 4. 2 times 2 is 4.
So we just always add whatever we bring out. Is
No,
that it?
okay, what-
Is that it?
multiply.
Or do you happen to find a happy coincidence here? And don't even give me that little eye roll of yours. I didn't spend 6 years in evil medical school to be called Mr. Thank you very much. So you multiply these guys. This is all multiplication. So 2 times 2 is still 4. Is there anybody that didn't come out? 3. You know what? And if you don't know how things break down, you could just start out like this. Take 48 and just keep factoring and breaking this guy down. You know that 2 goes into 48 how many times? 24, and 2 goes in here 12 times. Keep using 2 until you run out of being able to use that. 2 goes in there 6 times. You know what? 2 goes in here 3 times. Can I do anything else with that? No. So the numbers that you have here on the outside form your prime factorization. So you can pair up the 2's very easily when you do that. That way we're not bouncing around trying to figure out what goes in there. You start with your first prime number, 2. And you go into 3, and then 5, and then 7. And you'll be able to easily break down any number that you come across. Okay?
They should have said that's what that was a long time ago.
There are a lot of things they should have taught you a long time ago. For one reason or another, they did not. But that's why you've got me. And I've got you, babe.
That was like the simplest thing I've ever seen.
I think we need to spice things up a little bit, if you know what I mean. How about the cube root of 40? Now, this is a little bit different. The cube root of 40 means I'm not looking for perfect squares, but I'm looking for what? Perfect cubes. And you know what? If you've got your list of cubes, you're right. Here's my list of cubes. Do I see a 40 on my cubes here? No, but do I see any of these guys that could go into 40 evenly? Well, you know you can't do 64 because that's too large. 27?
8, I think. Isn't it?
8, I think.
8 times
Well, since we know in the
5
test that some people
is
think that 9 times 5 is 40.
8 times 5 is 40.
That's right. Isn't that so silly when people do things like that? Like, oh my gosh.
And 8 is a perfect cube.
Sweet sarsaparilla, you're right.
So
It
therefore-
is a perfect cube.
Sweet sarsaparilla. That's so country.
So 8 is a perfect cube. What is it the cube of? So that means this guy breaks out of here as a 2,
And leaves a 5.
and I'm left with 5 on the inside. Do y'all agree? Y'all agree with that?
Yes.
You should not agree with this.
Yeah.
Didn't you have an index of 3? ¿Dónde está?
The 3, yeah, we took it out though, didn't we?
You still have a cube root though.
Oh, yeah, put that there.
Because remember, your behind the scenes work that you have going on here is the following. You're breaking this down as the cube root of 8 times the cube root of 5. The cube root of 8 is 2, but then the cube root of 5, it just is. You could convert this to some crazy decimal, but I don't want you to do that. And you won't be doing that on a test or a quiz. You will be giving exact answers. Other questions about this guy? If you don't see the perfect cube to begin with, do what we did up here. Start with your smallest prime number, 2. Does 2 go into 40? 2 goes into 40 how many times? Can you still use 2? Okay, so 2 goes into 20 10 times. Can I still use 2? Then we keep doing that. 2 goes in here 5 times. 5 is a prime number, so when you get down to a prime number, you're done. So these numbers out here tell you the prime factorization of 40. Since I was dealing with a cube root, I needed to have either a perfect cube that was just a straight up number that was a cube, or I needed to have 3 of the same factor. So I've got 1, 2, 3 2's. Okay, so that constitutes a perfect cube for us.
That's why I put 2 in front of the,
Right, because that's why I get the 2 in front of the radical. 5 was not a perfect cube, so you could not simplify that. He stays inside. So those 3 factors of 2 is what gives me the cube root of 8 right here. And what is the cube root of 8? 2. Is the cube root still there for the 2? No, because the cube root of 8 is 2. Like if I say, what's the square root of 4? 2. Just 2, straight up, right? Same thing here with this guy. But why does the cube root have to stay on the 5? He's not a perfect cube. You can't do anything else with this. So you're done. Other questions?